How would you synthesize the target shown here? Well, in your design of this synthesis, step one is consider the functional groups that you need to make. And we see two. And there's something very special about one of them. It has to have the E stereochemistry. Now, when you're designing a synthesis, this is really helpful because you only know one method for making E disubstituted alkenes. Step two in your planning is count the number of carbons in the target molecule. This is a C7 compound. For step three, consider the molecules that are available for use in this synthesis. Well, we can start with hydrocarbons, all molecules having only carbon and hydrogen, alkanes, alkenes, alkynes, dienes, having at most 4 carbons. When you put together your method for making this E stereochemistry for this diene and your knowledge of how to make carbon-carbon bonds, they both point to the same thing. Use an alkyne as the precursor of this molecule. So we can write this could come from this alkyne that also has the terminal alkene functional group. And because we know that we can start with hydrocarbons having at most 4 carbons, and this has a 1, 2, 3, 4 carbon piece and a 1, 2, 3 carbon piece, it's pretty easy to conclude that we should make this carbon-carbon bond. And we know that this could come from precursors where we're making that carbon-carbon bond. We can alkylate a terminal alkyne with an alkyl bromide if the bromide is primary, which it is here. And then take a look at this. This is a primary allylic bromide. It can be made by radical halogenation at an allylic position. So here we have it. We could make this C7 diene starting with a 4-carbon alkyne and a 3-carbon alkene, propylene. This fits the pool of hydrocarbons that we have to start with, so all we have to do now is lay out the synthesis from beginning to end. Take a look. We could treat this alkyne with sodium amide to remove the proton. We can alkylate using this allyl bromide, which we make by treating propylene with NBS and light. Once we have this alkylated alkyne, it already has this alkene double bond in it. All that remains now is to reduce this alkyne using conditions that make the E stereochemistry, and we have the target molecule.